Vercel Functions Intermittent Invocation Errors, a DevOps Postmortem. It was 099 UTC on June 19, 2026, and for a subset of Vercel functions, the world just started to fray at the edges. It wasn't a total blackout knot at first, but it was a jagged, inconsistent nightmare. Requests were hitting the edge and simply vanishing into a void of errors primitive close errors. To the end users, the site felt like it was gasping for air. To the engineers on the back end, it was a ghost in the machine. For nearly 7 hours, these functions would trigger, struggle, and fail intermittently, leaving developers scratching their heads at why their deployments were suddenly buckling. The scale of the impact was creeping across the platform, caught in the crossfire of an invisible shift in the underlying infrastructure. Something fundamental had shifted under the hood, and while we wouldn't know the exact mechanism for a while, the damage was already spreading through the production environment. Picture this: it's June 19, 2026. And Vercel, the backbone for thousands of modern web front-ends, is hitting a massive snag in the engine room. To understand why this was such a headache, you have to look at what Vercel functions actually do. They are the invisible workers executing your back-end logic every time a user clicks a button. On that morning, starting at 099 UTC, these functions began choking on errors primitive close errors. It wasn't just a minor glitch, it was a fundamental breakdown in how the system handled requests because of an underlying Node.js version upgrade. Specifically, any function relying on the older Node fetch at 2 library became a ticking time bomb. For those developers, their apps weren't just slow, they were failing to execute entirely, leaving users staring at broken pages while the infrastructure struggled to keep its promises. It was June 19, 2026, and on the surface, everything was humming along just fine. The Vercel platform was handling traffic as usual, but underneath the hood, a silent shift was taking place. A recent Node.js version upgrade had been pushed across the infrastructure, the kind of foundational change that usually goes unnoticed until it starts to bite. For most users, life continued normally, but for a specific subset of functions, the ground was about to shift. These were functions relying on the Node fetch at 2 library, a combination that would soon turn stable execution into a lottery. At 0909 UTC, the first ripples appeared. It wasn't a total blackout. It was a creeping instability where certain requests started hitting a wall. The storm hadn't broken yet, but the conditions were perfectly primed for a very specific type of technical nightmare to unfold. It was June 19, 2026, and the morning was starting off relatively quiet until exactly 0999 UTC. That's when the first ghosts started appearing in the logs. It wasn't a total blackout knot at first, but a creeping, inconsistent failure across a subset of Vercel functions. The engineers on call didn't see a clean down signal. They saw a jagged spike of errors primitive close errors crawling through the system. It was the kind of intermittent noise that makes your skin crawl because it's hard to pin down. They were looking at functions specifically utilizing Node fetch at 2, which were suddenly choking out during execution. The telemetry showed these requests weren't just failing, they were being cut off midstream, leaving developers staring at broken connections and inconsistent results while the underlying Node.js environment behaved like it had lost its mind. It started as a ghost in the machine, a phantom twitch in the system that nobody saw coming until it was already spreading. At 0999 UTC on June 19, 2026, the first wave hit. It wasn't a total blackout. It was something more insidious, an intermittent failure. Specifically, functions relying on Node fetch at 2 began choking out with errors primitive close. This wasn't just a minor bug. It was a cascading incompatibility triggered by a Node Node.js version upgrade at the platform level. As the runtime environment shifted, these specific dependencies buckled under the new requirements, causing execution threads to snap prematurely. The failure rippled through the infrastructure, silently degrading service for any user caught in the crossfire of that specific library stack. It stayed in this volatile state for hours, a ticking clock of instability, until the team finally rolled back the environment and restored order at 16:16 UTC. So, what was actually happening under the hood? It wasn't a ghost in the machine. It was a collision between legacy dependencies and modern infrastructure. The root cause boiled down to a Node.js version upgrade on the Vercel platform that didn't play nice with node fetch at 2. Specifically, this environment mismatch triggered a flurry of premature close errors, because node fetch at 2 handles stream connections in a way that became incompatible with the updated node runtime. Outgoing requests were being severed prematurely. It wasn't hitting every single user, it was a subset of functions, but for those caught in the crossfire, the connection just dropped mid-flight. This technical friction turned a routine infrastructure update into a chaotic afternoon where functions simply refused to complete their work, leaving developers staring at broken streams and angry logs while they scrambled to find the disconnect. When the smoke cleared, we could see exactly how deep the fire had burned. This wasn't a total blackout, but it was a surgical strike on specific infrastructure that left some users staring at broken pages for hours. Starting at 9:09 UTC on June 19, 2026, a subset of Vercel Functions began choking on error-stream premature close errors. These weren't just random glitches. They were systemic failures triggered by a Node version upgrade that collided poorly with the node fetch at 2 dependency. For nearly 7 hours, these functions were basically shouting into a void. It took until 16:16 UTC for the environment to be rolled back and things to finally settle down. While it didn't take out every single user on the platform, the duration of that window meant a significant chunk of traffic was hitting dead ends, while the engineers scrambled to revert the core infrastructure. The alarms started screaming at 09:99 UTC on June 19, 2026, as a subset of Vercel Functions began choking on intermittent invocation errors. It wasn't a total blackout, which made it even more of a nightmare to pin down. It was ghost-like and inconsistent. The team dove into the logs and found the smoking gun, a flood of error-stream premature close messages. They quickly traced the failure back to the specific interaction between a recent node platform upgrade and the node fetch at 2 library. For the next few hours, the engineers were fighting a ghost in the machine caused by an environment mismatch. It was high-pressure troubleshooting until they identified the core conflict. By 16:16 UTC, the team managed to roll back the Node.js environment for those affected functions, finally silencing the errors and restoring stable operations to the platform. So, how did we finally kill the ghost in the machine? It wasn't some complex architectural redesign or a magic line of code. It was a hard rollback. The team identified that the chaos stemmed from an incompatible Node.js environment upgrade that specifically broke compatibility with node fetch at 2. To stop the bleeding, Vercel rolled back the environment for those affected functions to the previous stable version. By 16:16 UTC on June 19, the system stabilized and returned to normal operation. Moving forward, the fix wasn't just a button press. It was a mandate for more rigorous compatibility testing across diverse customer configurations before any platform-level upgrades go live. They also prioritized building a faster, more reliable rollback mechanism for critical infrastructure. It's about ensuring that when a global change hits, you have an immediate undo lever to pull before the error rates start climbing. Look, we can't just shrug off this as a weird bug. This was a textbook case of how deep-seated dependencies can turn a routine platform upgrade into a localized nightmare. When that Node.js version jump hit the infrastructure on June 19, it didn't just break a few lines of code. It triggered a specific incompatibility with Node Fetch 2. The fact that we sat in limbo for over 7 hours from 9:99 UTC until the fix at 16:16 UTC proves that it works on my machine isn't a defense when your production environment is pulling from shared libraries. The takeaway here is twofold. First, platform-level upgrades must be stress-tested against diverse customer configurations before they go live. Second, if you don't have a rapid, reliable rollback mechanism for core infrastructure changes, you aren't just managing risk, you're gambling with it. We need to build systems that fail gracefully, not ones that just stop working entirely. That's how Vercel turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.